Migraines are not simply headaches. They are complex neurological events that often involve changes in brain energy metabolism, blood flow, and sensory processing. One nutrient that plays a critical role in brain energy production is riboflavin, also known as vitamin B2. Riboflavin supports mitochondrial function, and growing research suggests that mitochondrial inefficiency may be one of the underlying contributors to migraines. This video explains how riboflavin supports energy production in the brain, why this matters for migraines, and how light sensitivity may be connected to vitamin B2 status. Mitochondria are the energy-producing structures inside cells. The brain has some of the highest energy demands in the body, and neurons rely heavily on efficient mitochondrial function. When mitochondria struggle to produce enough energy, brain cells may become more sensitive to triggers such as light, sound, stress, or changes in blood flow. This increased sensitivity is commonly observed in people who experience migraines. Research has shown that individuals with migraines may have impaired mitochondrial energy metabolism, which helps explain why nutrients that support energy production are often studied in migraine prevention. Riboflavin is essential for the production of ATP, the primary energy currency of the cell. It acts as a cofactor for enzymes involved in oxidative phosphorylation, the process by which mitochondria generate energy. Without adequate riboflavin, energy production becomes less efficient. In the brain, this inefficiency can increase vulnerability to migraine triggers and neurological stress. Riboflavin also supports antioxidant systems that protect mitochondria from oxidative damage, further supporting cellular stability. Light sensitivity, also known as photophobia, is a common feature of migraines. Riboflavin plays a role in eye and nervous system health, including the maintenance of tissues that process visual signals. Low riboflavin status has been associated with increased sensitivity to light and visual discomfort. This connection helps explain why some individuals notice improvement in migraine-related light sensitivity when riboflavin status is supported. Riboflavin deficiency does not always present with obvious or dramatic symptoms. Instead, it can contribute quietly to fatigue, poor stress tolerance, and neurological sensitivity. Modern diets that rely heavily on refined grains, low food variety, or chronic stress can increase the body's demand for riboflavin. Certain medications and digestive issues can also interfere with absorption. Because riboflavin is water-soluble, it must be consumed regularly to maintain adequate levels. Riboflavin is naturally found in whole foods. Rich sources include eggs, dairy products, liver, almonds, mushrooms, and leafy greens. A varied, nutrient-dense diet often provides sufficient riboflavin, especially when protein and overall calorie intake are adequate. Riboflavin has been studied in higher doses for migraine prevention in clinical settings. However, supplementation should be considered thoughtfully and in context with overall nutrition. Riboflavin works best alongside other B vitamins, magnesium, and adequate caloric intake. It supports energy production but does not act in isolation. This video is not intended to replace medical care. It is meant to provide educational context for why riboflavin is frequently discussed in migraine research. Migraines are complex and multifactorial, but energy metabolism plays an important role in brain resilience. Riboflavin supports mitochondrial function, antioxidant protection, and neurological stability. When riboflavin status is low, the brain may be more vulnerable to migraine triggers and sensory overload. Supporting foundational nutrients does not guarantee prevention, but it can improve the body's capacity to handle stress and maintain neurological balance. Thanks for watching.